Fiber optics. It is the branch of science deals with design and application of optical fibers. So we need to discuss what an optical fiber is. Optical fiber is a diagram of optical fiber. You may be studied in the lower classes. The phenomena of light propagation through an optical fiber is total internal reflection, TIR. Optical fiber is a thin, transparent medium made of glass, cords, or plastic to guide light along its path. ലൈറ്റ് ഒരു സ്ഥലത്ത് നിന്ന് മറ്റൊരു സ്ഥലത്തോട്ട് പ്രൊപ്പഗേറ്റ് ചെയ്യുന്നതിന് വേണ്ടിയിട്ട് നിർമ്മിക്കപ്പെട്ടിട്ടുള്ള ട്രാൻസ്പെറന്റ് മീഡിയം മേഡ് ഓഫ് ഗ്ലാസ്, കോർഡ്സ് എക്സെട്ര അതിനെ വിളിക്കുന്ന പേരാണ് ഒപ്റ്റിക്കൽ ഫൈബർ. It works on the principle of total internal reflection. Now we need to discuss what is total internal reflection. Let us consider two medium. One is air and other is water. Let the refractive index of air is represented by mu2 and refractive index of water is represented by mu1. There is an incident ray, there is a refracted ray. The refractive index of water is higher than refractive index of air. That is, here mu1 is greater than mu2. The incident ray make an angle theta1 with a normal, while the refracted ray make an angle theta2 with a normal. Light ray passes from a denser medium of refractive index mu1 to a rarer medium of refractive index mu2, where theta1 is the angle of incidence and theta2 is the angle of refraction. Let us see the figure. You can realize that as theta1 increases, theta2 also increases. Now, at a particular value of theta1, theta2 become 90 degree. That theta1 is called critical angle. That is, when theta2 become 90 degree, the corresponding angle of incidence is called critical angle, represented by theta c. The critical angle is the angle of incidence when the angle of refraction is 90 degree. If theta1 greater than theta c, the ray reflected back to the denser medium and the phenomena is known as total internal reflection. In short, angle of refraction theta2 is proportional to angle of incidence theta1. As theta1 increases, theta2 also increases. At a particular angle of incidence called critical angle, theta2 will be 90 degree. Beyond that, if you are increasing theta1, the ray will be reflected back to the denser medium itself. That phenomenon is called total internal reflection. So, two important points in case of total internal reflection are, one is mu1 should be greater than mu2. 2, angle of incidence should be greater than critical angle. According to Snell's law, we can write mu1 sin theta1 equal to mu2 sin theta2. When angle of incidence theta1 equal to critical angle theta c, theta2 is equal to 90 degree. You can substitute this value in the above equation. That is, mu1 sin theta c equal to mu2 sin 90. The value of sin 90 is equal to 1. So, mu1 sin theta c is equal to mu2. Or, sin theta c equal to mu2 by mu1. Theta c equal to sin inverse mu2 by mu1. It is the equation for critical angle. Parts of optical fiber. These are the two images of optical fiber. More specifically, step index optical fiber. Optical fiber has a core, and surrounding the core there will be cladding. Surrounding the cladding there will be a coating which is called sheath. A horizontal cross section of optical fiber is depicted in the second figure. So you can see a core. The phenomena of total internal reflection will be occurring inside the core. Light is propagating through this core, and there is a cladding here. Core is the cylindrical inner region of the optical fiber. It is the light guiding region. Cladding is the coaxial middle layer. It makes light to be confined to the core. Sheath. The outermost coaxial region of the optical fiber is called sheath. It is a protective layer. It protects cladding and core from abrasions, contaminations, etc. Also, sheath increases the mechanical strength of the fiber.